not working.
Most of my projects usually revolve around dev boards. I design them, I build with them, and at some point I realized I had drifted into autopilot. I miss the feeling of building circuits that don't depend on a microcontroller. I had this old book of 555 projects lying around, and the one that stood out the most was an electronic dice. The idea is elegant, and I'm going to break it down. When you roll a dice, essentially you can have 6 possible states to land. If we use the microcontroller, we could just connect the 7 LEDs, upload code, and get the job done. But to build it without one, we need to break down the emerging patterns. You'll notice that the middle dot appears 3 times, in 1, 3, and 5. Top left and bottom right corners appear in 4, 5, and 6. Top right and bottom left are in almost all dice faces except for 1. There's also a special pair of dots, only used in face 6. What this means is we essentially have 4 building blocks of a dice required to display any number. For example, if I want a 5, I would turn on D, F, B, and AG and then disable the CE. We can draw out a binary truth table for this to get a better look. Here, the pattern for 2 is highlighted, and it appears always except for 1. We can overlook and invert this logic using PNP transistor to simply keep it always on except for the dice face 1. Let's turn this into a circuit now. By using an NPN transistor, I can control LED D. For F and B, I'll use the mentioned PNP inverted logic, and LEDs AG and CE will just be simply controlled by an NPN transistor similar to the LED D. What we've built now are the first steps into making an electronic dice. Now we need to combine these 4 blocks into real dice faces. To do that, we need to find a way to loop through the 6 possible states. For example, for phase 1, I want my LED D to turn on and disable the 2 corners. Well, for phase 2, I don't need to do anything since 2 is always on due to the PNP transistor. For 3, I just need to add D, and so on for 4, 5, and 6. To automate it, I can use a Decky counter, which is a simple integrated circuit. The Decky counter is a sequential logic device that advances from one state to another on every clock cycle. Instead of using a button to loop through the LEDs, we can introduce a simple 555 square wave generator which will produce a clock signal. We can combine this with our Decky counter, and this in turn will also introduce a sense of randomness, since it will be difficult to always make it stop on the same phase. I can combine this with our original 4-block selector. What we have now is a press a button, generate a clock, loop through the Decky counter, and loop through the LEDs. However, as soon as I release the button, the dice stops and displays a number. But that's not what happens. A dice rolls and shakes before it comes to a stop. So we need to replace our 555 logic, and I didn't invent the circuit, so I posted a link to the original source in the description. Anyways, after building and optimizing the timing, I removed my old 555 timer and added a new one. What happens now is after I press a button, it loops the Decky counter, but if you watch closely, after I release the button, it takes a few more steps to roll. However, pressing a button isn't very dice-like, so I made a small adjustment to the circuit and added a vibration switch, which required only a single transistor to invert the logic. Now I could shake my breadboard, which turned on the 555, loop through the Decky counter, loop through the dice, and after stopping, it will roll just a bit more. We can build a PCB now. First, I cleaned up and polished the schematic and started drawing out the PCB. It's a 55 by 55 PCB board with through-hole components, so you can buy it as a soldering kit and build it yourself. After double checking, I exported, uploaded, and then it came. It's a beautiful 2-layer ENIC PCB with as much art as I could put in it. I added all the parts, soldered it, and there you have it, a microcontroller-less electronic dice. If you want to build your own, please don't hesitate. It's a fun project, it expands your soldering skills, and helps this channel grow.